Hi everyone and welcome for this second video. Last time on the first video, I introduced you the MATLAB code that I developed in order to identify and track a LEO satellite. So this is the code that you can see on the screen here. But today, I'm in the van on the field and I'm going to use this code in order to control a positioner with an antenna and track a LEO satellite. And the antenna, the LNB of the antenna is connected to a spectrum analyzer that you can see on the top of the screen, and we will observe the signal of the LEO over the time to show the good tracking capability. So this is the van. We have the computer with the MATLAB code that you have on the screen, the spectrum analyzer, all the different units also as well to communicate with the positioner. And if I came out of the van, so now you see the van, we have the antenna. So we have a tripod, on the top of it the positioner with a counterweight system in order to stabilize the full structure, and the KU dish antenna with the feed and the LNB. The LNB which is connected to the spectrum analyzer, and you see we have already a signal on the spectrum analyzer. This is the signal of a GEO satellite. It's a Eutelsat 16A, and I'm using this static satellite as a reference position. So I'm back inside the van. I think I showed you also as well that we were on the car park of the university, but back inside the van, I'm going to start now the MATLAB code. So I launch it. We have the user interface that appears like last time on the video. Sorry. Yes, I record everything during winter, so today I'm a bit sick, sorry for that voice, but so we have the user interface, we put all the specifications, we select the GEO satellite as a reference that we want, how many TLE data we want to download, the specs to what is the track satellite, what are the specifications for the satellite that we want to track, how many base stations, how many users we're going to have, and where they're going to be placed, etc., etc. And after the code, of course, is computing everything. It's going to download the TLE data, it's going to plot here on this first window the position and the orbit of all the satellites that you download, and is going to find one single satellite to track. This satellite that we are tracking now in Heriot-Watt, of course, it will be the same whether we are in Heriot-Watt or on the other base stations. And this is because the way that I compute the track satellite is based on the specifications. The specifications are not based on the position of one single user, but is based on the position of all the different users. What I mean by that is, like, for example, if you take minimum elevations, is one of the specifications. Here I put 50 degrees. A satellite will be visible if it's about 50 degrees, but not 50 degrees for me in Heriot-Watt. It has to be about 50 degrees for all the base stations. That's what I mean by the common specifications, and that's how we ensure that everyone is tracking the same satellite. If we run the MATLAB code at the same time with the same spec, of course. But here we have a satellite to track. It's going to be visible in 40 seconds. And in about 10 seconds, actually, the positioner is going to start moving towards the LEO. So 30 seconds before the end of the countdown, I start moving the antenna. Like that gives me enough time to reposition the antenna properly towards the LEO. So you see now the antenna start to move. You see azimuth and elevation now is moving. Actually, now I'm showing you also as well like that. You see the antenna moving. On the spectrum analyzer on the top, you see we have completely lost the signal of the GEO because we are not pointing at it anymore. And now we're going to start tracking the satellite just now. And now you see on the spectrum, I don't know, maybe you don't see it yet, I see it, but we start to detect a signal. So the signal is very low at the beginning because we are probably at the edge of a beam of the satellite. So we are pointing towards the satellite, but the satellite has multiple beams and didn't have at the beginning a beam properly pointing at us. But now you see the signal, it starts to be quite clear. It's still low, it's going to increase because we are still on the edge of that beam. but the signal is going to get stronger and stronger over time. And you see, we maintaining the signal. We are locked on the signal. And so if the antenna was at a fixed position, we will see the signal for 5 to 6 seconds, no more. The, the, the dish antenna that I'm using has a beam width of 3 degrees. So, so yes, we will have seen the signal only for a few seconds. But here you see the signal is quite stable and it's getting even stronger. Actually, we even detect a second beam. It's there now for quite a bit, but the second beam is very low. Yeah, this one, you see. But because we are at the edge of that second beam, so we don't care. We just focus on the main one, and that's it. So we managed to lock on the beam for over a few seconds. I mean, more than a minute, showing the good tracking capability. As I was saying, we will have detect the beam only 5 seconds if we were not tracking the satellite. And so at the end of the tracking, the antenna go back automatically to the GEO satellite, the Eutelsat 16A, and you see now the spectrum analyzer, the signal, we went back to the original signal it was at the beginning of this video. So the antenna is now ready to track a new satellite if needed, and that's it. So I hope you enjoyed this video. I hope you understand everything. If you have any questions, don't hesitate to contact me. My name is Samuel Rothenberg. I'm a doctor at Heriot-Watt University. And that's it for now. Bye. Thank you.